Hello AP Stats kids. Today we're going to be looking at a quick review of Chapter 5 to go along with your free response questions. Chapter 5 is dealing with probability and trees and diagrams, all sorts of fun stuff. This is going to be a long one, so buckle up. So, you guys know the drill. Please read the question. I'll go over it. Try it yourself first. That's the best way to do this. So, let's take a look at this. So, there's golden tickets. There's 95 kids parking. Each school, they give away 2 golden tickets. So 95 students. That's a good highlighter. There's 95 students parking. Each month they give 2 lucky winners. They want to know what 2 members were in AP Stats. And some people are like, hey, that was rigged, because there's only 28 kids in AP Stats, and the fact that 2 out of the 95 were AP Stats kids shows me it's rigged. So we want to tell whether or not it was plausible that the lottery was carried out fairly. All right? State plan do conclude. We aren't going to be doing any significance test. This is just a basic simulation. So let's do our state. So what are we trying to find? You're trying to find what is probability of getting cursive 2 winners from AP Stats, aka we're finding what's the probability that x equals 2, where x is winners from AP Stats. All right, so what's our plan? We're going to have to carry out a random sample, because in Chapter 5 we didn't have all the tools in our tool bag that we currently do. So our plan, we're going to assign, please write this in paragraph form when you do it, numbers 1 through 95 to each student. Then we're going to also assign 1 through 28 to AP students, right? Oh, I forgot it does this. Wicker Whiskets. Whatever, I'll make this work also right over here. Then what we're going to do is we're going to select 2 with random digit table. And we're going to skip duplicates and numbers that aren't on there, right? Right, we're going to pick 2-digit numbers like 00. It's going to be nothing. 97 is nothing. Okay? And we're going to run 18 simulations just because. All right? Make sure, this is important, guys. Whenever you are planning out an experiment like this, you need to include the tool you're going to be using. We're using a random number table. You could say calculator, random number generator, dice, whatever. You need to give the values. Like 1 to 95 is the values we gave for the 95 students. We need to say how many we're going to select 2, and how many simulations we're going to run. We need to say what we're going to do with the duplicates, repeats, numbers that don't count. And we need to say what we're going to record, and we're going to record double yeses. You'll see what I'm entailing. All right? I'm going to pause to make sure that my sound's working. It is. All right, so now let's do it. You guys are going to trust me on this? I reckon you have no choice. All right. So, first time I did it, I got number 55 and 58. Are both those in AP Stats? No, because Stats is 01 through 28, right? The next time I ran it, I got 89 and 94. Are those both in AP stats? No. Next time I ran it, I got 404 actually, because I'm using a digit table, and 70. Ones in stats, but not both. So no. Next time I got 10, 98, and 43. Why did I do 3 drawings? Well, 98's not within our range, so we skip it. We have one, but not the other. All right, and I did so for a long time. I got years. All right. So what conclusion can I draw? All right. Based on our simulation, both students, that was in my capitalized, selected were in AP Stats 16.67, 3 out of 18% of the time. So it is, remember that's over our magic threshold of 5%. So it is plausible to have both kids in AP Stats, okay? So it's plausible, so it's probably not rigged. Can we guarantee it isn't? No. But it's plausible it's not rigged. There's no evidence against it. Alright. That's 5-1. Let's look at 5-2. First one's E, not too bad, right? We're looking at a basic probability distribution. Okay? Again, pause it, try it, live it, love it. You're almost done with stats, guys. You only got a month left. Technically, I'm going to try to give you all your materials. Technically, you only got 2 weeks of school left, so I'm just going to get you all your stuff and maybe let you guys do what you need to do. Alright. What should all these probabilities add up to, y'all? That's right, they should add up to 1, 100%. Because 100% of people are people. So if I do 1 minus these, I find out that this other is 0.09. Why? Because they all need to add up to 100. So let's do this. What's the probability that a Canadian's mother's tongue, just her tongue, not her language, is not English? That makes no sense. I hate the way they word these, but I get it. So not English. So that's complement, right? You can think about it as E complement. So we subtract, right? 1 minus the chances it is English. I get 0.37. You could have also added up these 3 and gotten the same answer. Okay? Now, what's the probability that her language is different than English or French? Now, again, I could do 1 minus English and French, or I could just add up the 2 that are not English and French and get 0.15. Both ways work. Sorry, I went through this one relatively quick, but it is what it is. Jump cut. All right. So we're looking at a 2-way table, males and females, Democrats, Republicans who are in the U.S. Senate in the most recent year. I don't know what year that is. Just stats is stats. So who are the individuals? Pause it. Try it. The individuals are the senators, right? And what are we measuring? What is being measured? Well, who's Dem and who's the Rebs? We're also measuring males and females, right? Let's do some stuff. What's the probability that we randomly choose a senator who's a Democrat? So in order to do that, we need to know total Democrats. So I add these up and I get 60. Now there's 100 people in the Senate, history lesson, cross-curricular activity. Let's go. So it's 60 out of 100. Boom. What's the probability of finding a female? Just straight females. So I'm going to add up my females and I get 17. Right? There's 17 total females out of 100. That makes sense. That's a cross section of the country. What about a female Democrat? So I'm looking at female Democrat. I'm just looking at this square right here. So it's just 13 out of 100 because that's where they intersect at. Now what about a female or a Democrat? Now there's two ways to do this, okay? Way one would be we add up all the female and the Democrat spots. So what I mean by that is I add up how many male Democrats, female Democrats, and Republican females. Because they all count for this. So you do 47 plus 13 plus 4 is 64 out of 100. Or you could have done it the other way, where you add them up and subtract the overlap. Because I have 60 Democrats plus 17 females minus 13 Democrats who are females. That way I also get 64 over 100. Okay, both ways are fine. You could add, subtract the overlap, or just add them all individually. Whatever way works for you. All right? Guess I told you this was going to be a long one. All right. Read it. Try it. Watch it. Love it. Draw a terrible thing. So we're making a Venn diagram between landline, cell phone. Right? Now, this first box. Who has a landline and a cell phone? So that's going to be this box right here, right? That tells me they have a landline and a cell phone. Now, landline and no cell phone. That means they have a landline, but they don't have a cell phone. And cell phone, no landline, is going to go in this box. And if you don't have neither, you're in the white box. So 0.6 goes in the... I'll put 0.6 here. 0.18 here. 0.2 here. And then 0.02 have neither. Alright? Makes sense? That's beautiful. So down here it says, find the probability that a household has at least one of the two types of phones. So that means you can either add these three up, right? And you get 0.98. Or you could have done 1 minus the people who don't have any and still get 0.98. Alright? Them off the grid people. Sounds nice some days. Alright. Hopefully you have that diagram down because I'm going to go do this one. What's the probability that they only have a cell phone? Only have a cell phone was 0.2, right? That means they have a cell phone, but not a landline. Also right big. Boom. Alright, we good? Let's go to 5-3, number 1. Probability of a flush. Depends if your toilet works. Alright. So a poker player, a flush is when you have all 5 of the same suit, right? 5 hearts, 5 clubs, 5 spades, da-da-da-da-da. There's 13 of each of those in a deck of cards. You don't play with a joker because that'd be silly. So what's the probability that the first card dealt is a spade? Well, if there's 13 spades and 52 cards, right? Or you could also think about it as 1/4. Because a core of the cards are spade, not times. Sometimes. Now, conditional probability says it depends on what the other draw was. So what's the probability that the second card is a spade if you know the first card is a spade? So you draw one card out. It is a spade. So now how many cards are left in the deck? Well, 51. How many of those are going to be spades? Well, 12. All right. Now let's keep doing that. What's the probability that third, fourth, fifth card, each case, is a spades? Oh my gosh, I hear a kid wailing upstairs. All right, I'm actually just going to do this because this is what works for me. So first draw, I have a 1/4 chance of drawing a spade, right? Then after I draw that spade, on the second draw, there's only 12 spades left. There's 51 cards left because I drew one out. Now, assuming I drew a spade, 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 no, just a spade, spade, a David spade. My third draw, I drew another spade. So now there's only 11 left, and there's 50 cards because every time I draw a card, it's gone. Now, on the fourth draw, I drew another spade, so there's one less, and there's one less card. And on the fifth draw, again, I'm just subtracting one from both those because I keep drawing spades. Okay. Now the probability of being dealt all 5 spades, you multiply those, right? Because it's a dependent probability. Remember, it's dependent, you multiply. So for C, I'm just going to multiply all these probabilities to find the total probability of being dealt 5 spades, just to yourself. There's other people it changes the probability a lot. And when I do that, I got 0.00044951. Okay? I'm going to leave that number there. That's a magic number. Wish I could move it. Alright. Use different color for D. Alright. So now that's just one way to get a flush. You could have also gotten 5 hearts, 5 diamonds, 5 spades, or 5 clubs, right? Now, what's the probability of just being dealt a flush? Now, one way you could do it is you could go through and you could skip the first card because the first card doesn't matter. You just need to match it, and then you just use the second part of the probability. Okay? I don't like that way. Here's how I would do it. This probability of a flush, there's 4 ways to get a flush. You times that by 4, and that would give you 0.1898. Okay? We good? All right, let's go. Internet sites says 13% of references don't work after 2 years. If they had 7 references, what's the probability that at least one of them does not work after 2 years? So at least one doesn't work. So now you could go through and find the probability that 1 doesn't work, 2, 3, 4, 5, 6, 7. That's going to be a lot of work. It'd be easier if at least 1 doesn't work. That means it's the complement of all of them work. So it's the opposite of all of them work. So to do this one, I'm going to do 1 minus they all work. That's going to be a lot easier. And that would equal my probability of at least 1 error. So what's the probability that they all work? Well, what's the probability the first one works? 0.87. What's the probability the next one works? 0.87. And dot, 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 dot. Right? And then you multiply them just like we did with the CODs. So shortcut way is you do 0.87 to the 7th. So I do 1 minus that to get probability that at least, it's to complement at least one error. I'm going to break my computer. I keep hitting the flash drive. When I plug that in, I get 0.62. That's a 2.27. So there's a 62.27% chance of finding a paper that at least one of them doesn't work. Okay, if it's 7 sources. The link doesn't work, not that the source was phony baloney. Alright, let's look at this beast. So they went to Emory University. 40% use Macs, the rest use PCs. 67% of kids are undergrads, the rest are grads. In the census, 23. They both find this is, if you're given 2 different variables like this, you're going to want to make a chart, a two-way table. Macs, PCs. And then undergrads and grads, right? Now the first thing I would do when I fill out one of these tables is I find out one of the overlaps. This is an overlap. A grad PC user. So that goes in just one box, 0.23. Now, 40% use Macs, total. So that means that these have to add up to 0.4. Now, which means these two have to add up to 0.6, because they have to add up to 100. 67% were undergrad, so 0.67 goes here. Which means 0.33 goes here because they have to add up to 100. So if this is 0.33 and this is 0.23, this has to be 0.1 because they have to add up to equal 0.33. This one has to be 0.3 because 0.3 plus 0.1 is 0.4. And lastly, this one's going to have to be 0.37 because they have to add 0.67. Now our job's a lot easier. What's the probability? You know they use a Mac. It's return of the Mac. Don't copyright infringe me. Oh, highlighter is too small. I hate Epic Pen compared to the InterWrite software. But I don't have that anymore. So we're just looking at Mac users. So what's the probability that a person who's a Mac user is a graduate student? Well, I do 0.1 over the total 0.4, which is 1/4 or 25%. Alright guys, we're almost there. Alright, many employers make people take a drug test. Sometimes you get false positives, sometimes you get false negatives. So, we want to know what percentage of people who test positive actually use drugs. We're going to want to make a tree diagram for this. There's 2 types of people in this world. People who use drugs, that's actually a generalization. People who know drugs. About 0.4 or 0.04% of people use drugs, or 4%. 0.96 don't. Now, if you're a drug user, you're going to have positive or negative tests. If you're on the drugs, your chance of a positive test is, or your chance of a negative test, a false negative, is 0.1. So your chance of a positive is 0.9, a true positive, right? Now, if you got the no drugs, you do have a chance of getting a positive. And your chance of getting a false positive is 0.05. That means you are not on drugs, but you tested like you were. Which means you have a 95% chance of testing negative. So, what's the chance that you test positive and you're actually on the drugs? Well, these are your probabilities that you test positive, right? You multiply across. So 0.04 times 0.9 is 0.036. 0.96 times 0.05 is 0.048. That's the total. So what's the total chance of someone testing positive? Well, I add them together, right? But now what's the chance that just positive was a drug user? Is 0.036. So I put that on top. And when I divide them out, I didn't divide them out. I'll leave it like that so you can see it and see where I'm coming from with that. We have one more page, y'all. This might be the longest video in history until I make chapter 6. And that will probably be the longest. And there'll be 10 people who watch it, and then AP Stats will be like, whoa! Wait. Is that it? Nope. This one. There's 2 sneezes. Alright. Pause it. Try it. We're almost there, you guys. So we're given a two-way table, and we're going to choose 2 students at random. Draw a tree diagram to show the sample space for this chance process. We're looking for just allergies, not the sneezers. Okay? So think about this. What are the 2 types of people in the world? Those with allergies and those with no allergies, right? So what's the chance that the first person I draw has allergies? It's 18 out of 40. What's the chance they don't have allergies? 22 out of 40. Now, let's get tricky. Now I'm going to draw a second person. They can either have allergies or no allergies. Now, what's the chance they have allergies? Well, my first pick, I drew someone with allergies. So now there's one less person with allergies and one less total person. Now, my number of non-allergies will not change because I didn't draw one with allergies. I didn't draw one without allergies. I drew one with allergies. But my total still goes down because I drew someone. This is dependent, right? 2 types of people. Allergies. No allergies. Now I drew someone without allergies. So there's still 18 people with allergies out there sneezing around, getting their mucus everywhere. Whoa, I knocked over a chair. And there's one less person now because I drew someone without allergies. Now, since I drew someone without allergies, that number goes down 1. They both go down 1, right? That's my tree diagram. Now, find the probability both students selected suffer from allergies. So what I'm going to do, here's allergies and allergies. You multiply, this is the only one that's AA. You're going to multiply across. Hey, why does it do that? Oh, jeez. I'm going crazy. And when I multiply those across, I get 0.19615. Alright. Oh, jeez, I'm going to need a... Oh, jeez, Rick. I'm just going to do this. We'll make it work, guys. Ah, jeez. Alright. What's the probability that neither student suffers from allergies? So that's a no. I said no. And I multiply those across. .029615. What's the probability at least one Hey, suffers. Whenever you see at least one, your path of least resistance is to subtract. Okay? To do 1 minus they all do. Right? And we found that up above is 0.19615. It's 0.7. That's not 0.7. No allergies. At least one. No, I did that wrong. Hold on. I wrote down all my answers wrong. This was not 0.0. This is 0.29. Okay. And that neither student has it is 0.29615. Phew! So that's 0.70385. We did it. Work was right. Problems wrong. Well, about one suffers from allergies. At least one. So for that one, I'm going to multiply these two and multiply these two, because those are my two with 1, and add them together. Okay. Try it out. I got 0.50769. Or I could have done 1 minus no allergies and all allergies, my two numbers from before, right? And that would also work. Alright guys, long video. It's going to take me an hour to upload with my internet. Have a great day.